Hey class, hey, welcome back from the week break, Christmas break. Before we went on break, we started trig and polar coordinates, but we kind of stopped short because one I knew was not going to be on the final, and so I decided we can pick this up on the other side of Christmas break. All right, and so we lost like a day or two. Lesson. And so I'm gonna pick up the pace a little bit for this lesson here, hoping it pop back up. Polar graph. Here is a polar graph right here. And so this is the center, but it's called the pole. This is called the polar axis. It's like your x-axis. And then each circle represents the distance or the radius from the center, right? So you can call this 1, 2, 3, and 4 units from the pole. Or you can this is your graph, so you can change scale, just like in XY plane. You can modify your the scale, right? I can call this 2, 4, 6, 8. However you see fit when you graph these points. Okay. All right. Back to plotting points now. A polar coordinate has an R value and an angle. Here we have 2, pi 6. And so this point now, the angle is pi 6. So that's right here. And 2 is 2 units from the pole on that angle. So 1, 2. So that is your point right there. All right. If again, power 6 means that we're going counterclockwise, and this direction is a negative angle. And so if this was a negative power 6 now, suppose we had 2, negative power 6. This means that I'm going in the clockwise direction. This will be negative power 6. And the R value is still 2. So the 1, 2, so that would be 1. All right. Okay. What else? What happens when the R value is negative? Okay. So let's look here. Suppose this was a negative 2 now. Okay. All we're gonna do is we find our angle power 6, right? But this time now, instead of counting to the right, right, 1, 2, I'm going to count in the opposite direction. So it's going to be 1, 2. So that's going to be my point right here. Good. All right. Let's look at this one here. It's negative 3, 7 power 6. So I find 7 power 6. That's the angle right here. Okay, so now I'm going to count now 3 units away. All right, so I'm going to go in the opposite direction. So it's going to be 1, 2, 3. That's the mark point. If this was a positive 3 now, then I would have gone 1, 2, 3 right there. But it's negative, right? So I go in the opposite direction. Good. All right, and so that's how we handle a negative R value. Okay, there are 4 different ways you can represent a polar point. And let's see how we can do this. Let's go back and look at 2, pi over 6, right? We agreed that point was right here at 1, 2. That's the point right here. Now, if I ask you to graph or to plot this point, say negative 2, 7 pi over 6. Okay. Where would that point be? Well, let's see. This is 7 pi over 6 right here. Okay. Now, because R value is negative now, I'm going to count, I'm not going to count this direction, right? Because R is negative. I'm going to go away from 7 pi over 6. I'm going to go 1, 2. But realize now, oops, that's the same point as 2 pi over 6. Right? So negative 2, 7 pi over 6, right, is the same as 2 pi over 6. Again, just to reiterate, I find my end of 7 pi over 6. That's right here. But because R is negative now, I'm not going to count this direction. I'm going to go away. So it's going to be 1, 2. So it end up as the same point as 2 power 6. All right. So negative 2 power 6, negative 2, 7 power 6, and 2 power 6 are the same. Now, what is the difference between those 2 points? Well, here, the R value is positive, here it is negative. All right. So if we look at a formula, R comma theta. Okay. Here, the R value is positive. Here it is negative. All right. So a negative R negative now. Now, power 6 and 7 power 6. What's the difference between these 2 points, these 2 angles? All right. This is power 6, and over here it is 7 power 6. Right. The difference between these 2 angles is they're along the same line. The difference is pi. All right. If I add pi over 6, if I add pi to this angle over 6, it gives me 7 pi over 6. Okay. So here now, right? If I flip the R value and make it negative, and I add pi to the original angle, I end up with the same thing. All right. Hope you guys see that. Okay. So one way of rewriting this point right here is, let's go back here and look at it again. Okay. All right. I will represent this point in another way. I can flip the R value, make it negative, and then add pi to the angle. And that gives me 7 pi 6. And that is the formula right here. Flip the side of the R value and add pi to the angle. Good. Here now, another way you can do this is this. Instead of adding pi, that means I went counterclockwise, right? What if I went the other direction? That would be, I'll be minus pi, right, to get to the same angle. Okay, so if you look at this now, let's erase this for a second. Pi to 6. If I minus pi from that angle, okay, in the negative direction now, I should end up here. All right. And this angle right here going in this direction is going to be what? Well, let's see. This is 1, this is negative pi 6. Okay. This is 2 negative pi 6. This is 3 negative pi 6. This is 4 negative pi 6. And this is, I miscounted somewhere. Pi 6, 2 pi 6, 3 pi 6, 4 pi 6. Yeah, this should be negative 5 pi over 6. All right, so this angle here should be negative 5 pi over 6. Let's see if we do that now. So when I'm minus, if I go this direction now, right, I'm minusing pi. Let's see if I get negative pi over 6. So this becomes 6 over 6. Pi minus negative 6 gives me negative 5 pi 6. All right, so I end up back at the same angle. So another way I can write this as, again, I'm going to keep the R value the same, but I'm going to minus pi, right? And I end up at the same angle or the same point. Good? Okay, all right. So now I'm showing you now 2 ways of representing angle. You can, another way you can do this is you can flip the R value, make it negative 2, and you can add pi, right? Or you can also, instead of adding pi, you can minus pi, and that will give you the same point. Okay. Another way you can write this point now is this. Let's go back and look at this. The ultimate point was 2 pi 6. That's right here. Okay. We know, right, if I go 1 revolution around the circle, I'm back at the same point. right? So that angle now, right? If I add 2 pi to the angle, I'm back at the same angle. So here, right, I'm not going to put R value now. R value is going to stay the same. So here, if I keep the R value the same, do not flip it, but I'm going to add 2 pi, I'm back at the same point. But if I went this way, all right, as counterclockwise, if I go this way, I can also go the other direction, all right? If I go this direction now, I'm going to minus 2 pi. I'm going to end up at the same location. So here I can write this as, keep the R value the same. I'm not going to put the R value, but this time I'm minus 2 pi. I end up at the same location. Good? So there's 4 different ways you can write the angle, all right? 4 different ways. Good. And you'll see now, we can abbreviate this now. We can say R comma theta, right? I can write this as, put R value, and the angle I can add or minus pi. That's these two right here. Good. Or I can keep the R value the same, but this time I'm going to add 2 pi or minus 2 pi. So we'll say plus or minus 2 pi. Good. So that's a compact way of writing. All right, guys. Yeah. This is just practice on these and straightforward. All right, let's jump on to convert polar to rectangular coordinates now. This can be a little bit confusing because we're end up doing 4 different ways of going back and forth with these things. So what we're saying is this: we're going from polar to rectangular. We're going from R, a polar point, to a rectangular. And that's what we're doing. And then I'm going to show you how we can go from a rectangular point to a polar point, R comma theta. Okay. Let's do the first one first. Let's do the first one first. Polar to rectangular. Good. All right. Here we go. So the first one they have is 6 comma pi over 3. Okay, let's see how we can convert that to rectangular. I'm gonna go, I have a blank, here we go. Okay. So 6, okay, here on this graph, right, there are only 4 circles. So I'm gonna rename this. Now again, you can change this as how you see it, okay? Let's call this 2, 4, 6. Okay. So my point now is pi over 3. It's pi over 3, right? Yeah. 6 comma pi over 3. Good. So that's this point right here. All right. Good. Now, what I'm going to do this now is, again, I'm going from polar. So this point is a polar point. I want to convert this to rectangle. So I'm just going to show you, I'm going to give this formula and show you how we write the formula. So this point now, what we're looking for is the x comma y. All right. The formula for the x is x is equal to r cosine theta, and y is equal to r sine theta. Okay. But how do we get these formulas for x and y? Well, we'll learn this within the unit circle, but I'm going to go back and show this quickly. Now, suppose I go ahead, I'm going to drop, I'm going to put a XY plane on the polar. So let's suppose this is my y axis, that is my x axis, all right? And you can see where I'm going with this, all right? What I'm going to do now is this. This point right here, I'm going to make a triangle, a right triangle. So this distance is the hypotenuse. This is the height triangle, and that is different color. That is the hypotenuse, This is the height, and that is the base. Okay. Well, the R value, this is right, we know that is 6. That is 6 units from the origin. So this we know is 6. R is equal to 6. Okay. All right. So what is, so this is my X value, and that's my Y value, the base and height of the triangle. And this is the angle of theta. But we know what theta is. Theta is pi over 3. Right? The angle is pi over 3. We know we can use split function to write a formula or a ratio between x, the angle, and r. We can use split function for that. This is the adjacent side. This is the hypotenuse. So I can write this as cosine of the angle is equal to the adjacent side x over r. Good. But if I want to get x by itself, I multiply both sides by r, and that gives me x is equal to r cosine theta. That's how we end up with the formula, guys. Right? And similarly for the y, do the same thing. Opposite over hypotenuse is sine. And so y is equal to r sine theta. So make sure you understand how we get these formulas. All right. Now, if this was a unit circle, right, then r would be 1. If this was a unit circle, r would be 1. It would be x equals cosine theta. All right. So we can easily find our x. We know what r is. R is 6 because that is the polar point was r was 6 comma pi over 3. R, the distance from the center is 6. So r is 6. And the angle is pi over 3. And so cosine pi over 3 is 1/2. 1/2 times 6 is 3. So that is 3. Good. For sine, the angle is pi over 3. R is 6. And that gives me now 6 times sine of pi over 3 is for the 3 over 2, which is equal to 3 radical 3. So the x and y value now. So x comma y, right? X comma y in a rectangle coordinate is going to be 3 comma 3 radical 3. That's what you do that. So the formula is, again, this is the formula right here, guys. Good. All right, so I went the long way. I showed you how we derive this formula again, and so given, right, you're given this 6 comma pi over 3. That is a polar coordinate, right? This is the r value. 6 is the r value. That is our value, and the angle is pi over 3, and that's how you find the x and y value. Good. All right, so that's very long. And then. So the rest, I'm gonna have you guys do the rest. Pretty straightforward. Let's go back up to where we are here and scroll down, right? So you should have no problem doing 4. Okay. Let's look at converting. We're going the other way now. We're given the rectangular, and you want to go back to polar. So now we're going to x comma y to r comma theta. Good. All right. So here we go now. Let's do this real quick. -3 and 5. Wait a second. Okay. All right. So here we go now. Extend this first a little bit. Okay. So we're given -3 comma 5. So let's look at this. This is a rectangular, okay? And this point, -3 comma 5 is over here. Okay, so let's call this -3 right here. Let's call this 5. So this point is somewhere here. Okay. And we want to find r comma theta. Right, the polar point. So we need to find the angle, I'm going to find R. Again, R is the distance from the origin. So I want to find this distance right here. Okay. And see where I'm going with this, right? Right triangle again. If I draw a right triangle, good. And so this is the angle. Okay. We're going to use the reference angle. The angle we're looking for, this angle right here, R theta, this is the angle we want, right? From the origin. Okay. But we're gonna use the reference angle to help us find this angle right here. Good. And so we're going to use a right triangle. So we know this is 5. That's the height. Okay. So we can, obviously, you can see how we can find this. This is right here, R. That's just the Pythagorean theorem. And so R is going to equal to the square root of -3 squared is 9, plus 5 squared is 25. And that's going to give me 30. That is equal to the square root of 34. And that I can't simplify any further. No, no, 2. Now that's it. Okay. Now, how do we find the angle of theta? Now, I'm going to give you the formula. I'm going to show you the right. But after that, I just want to make sure you understand how you get the formula. The angle theta, right, reference angle theta is equal to the tan inverse of y over x, the y value over x value, right? And the y value is 5, and the x value is -3. Now, how do we get that? Well, so remember, I'm going to start from number 1. I'm going to use this formula right here. So when I show it, obviously right, make sure you understand. We did this earlier in unit when we did trig functions and the I have a brain cramp right now. It's going to come back to me. All right. So how do we get to that? Let's see. Now I want to find the angle right here. Well, what do I have here? I have the opposite side. I have this side and the adjacent side. Which trig function can I use to get an angle? Right, tangent. So tangent of the angle theta is equal to opposite side, which is 5. That is your y value, right? Hey, opposite side, which is 5, over the adjacent side, which is your x value, right? Y over x. So whenever you give it a point, x, y, and you want to find the angle, right? Right? Just use a tangent, right? And we do the inverse tangent. Okay. And so now tangent theta is equal to 5 over -3. To find the angle, now we do the tan inverse, right, of 5 over -3, which is the y over x. So make sure you understand that. Good. And now, so we put this in our calculator now, right? Erase this for a second now. If we do this on a calculator, that's going to give me, let's see, calculator. Okay, that's going to give me negative, oh, my glasses. I can't see the calculator. Give me a second, guys. Here we go. Man, my eyesight again. Okay, so that's going to give me negative 1.030. Now, I'm going to go one more this negative 1.030. I'm going to go one more this one place. Why is that? Because this is not my final answer. I'm going to show you why. Just because I want to make sure I don't make an error by not including another decimal point. Okay, that's not my final answer. So we know we take the inverse tangent, right? If you guys remember this now, the inverse tangent, because the input value is a negative number, it's going to return an angle in the 4th quadrant. If this input value, if this was a positive number, it will return an angle in the first quadrant. So a negative input right here gives me an angle in the fourth quadrant. A positive input right here gives me an angle in the first quadrant. That's the same for sine and tangent. Make sure you understand that. So this angle now is in the fourth quadrant. Negative. So this angle, I'm going to erase this for a second. This angle right here, all right, is in the fourth quadrant, and I'm going to guesstimate this, so this is negative 1.0303. But that's not the angle I want. The angle I want is in the second quadrant. Okay? And if you notice now, they are directly opposite each other. So to get this angle right here, all right, I'm just going to add 180. To add 180 now, or just pi. To add pi, it gives me the angle I'm looking for. Okay? So if I add pi now, the angle I'm looking for is, I add pi, that gives me 2.112. That is equal to 2.112. All right, three different places. All right, guys. So that's the angle. All right. All right. So to make this really nice and compact now, my R value is so we went from what is it the point? Okay, went from -3,5, and the polar point now is R is square root of 34, and the angle is 2.112. All right, that's it. Okay. All right, so the tricky part here is how to find angles. Just make sure, if your angle falls here in the fourth quadrant, okay, and again, one of the issues, it tells you if there was no restriction. Okay, let me make a point. If it did not give you a restriction, right, then you could have used this as your angle. Well, no, again, you can't because the point is up here. Okay, the point is right here. Hit the back. Yeah. Let's forget about this one. Right. The point is in the second quadrant, so we have to add pi to that. Okay. I'll think about something else. All right. So we can do one more of this before we move on to something else. Okay. Let's look at 5 power 4. All right. All right. So I'm going to erase this. No, that's some polar. That's some polar. I'm sorry. Let's use this one. 2,6. All right. Let's do that. I'm going to erase this. I'm just going to erase, and let's do number 2. All right. Let's see. Okay. Let's erase. Let's draw now again a rectangular coordinate system. Okay. The point is 2,6. So let's call this 2 right here. And let's call this -6. So the point is in the fourth quadrant somewhere down here. Okay. All right. Good. Again, we're given, we want to go from x, y to r theta. So I need to find the r value, which is going to be the distance from the origin. Good. You see where I'm going with this, right? A right triangle. So we know this distance is 2 units, and the height is -6, right? The height is right there. That's -6 right there. And so, okay. This should have been, oops, sorry about that. Okay, I should have drawn this on this side here. Oops, sorry. Okay, so this is 2, and this is -6. Okay, I can't draw it here because again, the angle I'm looking for is the reference angle, and that has to be with the x-axis. All right, just make sure you see what I did wrong there. All right, that's how we draw a triangle. The angle has to be next to the x-axis. All right. Right. So again, we can find R value really quick, guys. The distance from the origin, right? The R value is just Pythagorean theorem. So we're going to say R is going to equal to the square root. It's going to be 2 squared is 4 plus -6 squared is 36. That gives me the square of 40. And 5 8 is 40. So I can write this as, let's see. Okay, let's simplify this a little bit. So let's see how we're going to do this now. Okay, so let's see if I can write this as the square root of 4 times 10. 4 is perfect square. That gives me 2 radical 10. All right, so that's my radius right here. That's our value. Now, again, over the angle, how do we find the angle? Right, theta is going to be equal to the inverse tangent of y over x, right? So it's going to be -6 over 2, which is -3. All right, see that? Oh, we got to see that. That equals to -3. That's the angle. Okay. All right. And so again, when I take inverse now, this angle is that it's going to be the fourth quadrant. All right. And so let's do that now on the calculator. Let's see. Let's do it really quick. Inverse of -3. That gives me -1 point something. That gives me -1.24905. Okay. Again, I'm including more. That's not my final answer. I want to make sure I have this one place it when I round up. When I round, I don't get it the wrong answer. But is that the angle I'm looking for? No, because it says that the angle must be between 0 and 2 pi. This is a negative angle, right? That's not angle 1. So to find this angle now, right? If I go around the circle and add 2 pi to it, that's going to give me the angle I want. So therefore, if I add 2 pi to this, okay, all right, I'll get the equivalent angle, which is between 0 and 2 pi. If I add 2 pi, that's going to give me plus that gives me 5. Now I'm going to round it now. I'm going to round. That gives me 5.034, or truncated. Okay, 5.034. That's the angle. So what I'm looking for now, my R value is going to be for this one is going to be this. It's going to be 2 square root of 10, and the angle is 5.034. All right. All right. Let's move on to something else. All right. Okay. Let's see where we're at now. Okay. Here. Okay. Complex number. All right. A quick review of complex numbers, guys. We learned this in Algebra 2. All right. How do we get complex numbers? It's usually when we use the quadratic equation. All right. If you remember in Algebra 2, let's do all right. So let's extend this real quick. So remember in Algebra 2, right? You get a quadratic equation to find the factors, and you get x is equal to minus b plus and minus square root of b squared minus 4ac, right? Now, this becomes a quadratic expression. This becomes a complex number when we call this right here a determinant. When this is a negative number, right, you can get a square root of a negative number, and that gives you an imaginary number. So when this is negative, your answer becomes x equal to minus b. Oh, I'm sorry, this is 2a. This is over 2a, right? 2a. This gives you two answers now. X is equal to minus b plus, right, the imaginary number, whatever that is, and x is equal to plus a positive b, right? I'm sorry, minus b minus the imaginary number. So that's how you get complex number. So, right? And so that's where this comes from, right? You have the real number and the imaginary number. So that's where that comes from. Let's go back to here. Good. So we call that complex number. So that's where it comes from. All right. And so we can plot this now like an XY plane. We call the x-axis the real number. That's what we plot the real number. And the y-axis, that's what we plot the imaginary number. So in this case, right, this is z, but when we do quadratic, we say x is equal. We just call it z now because z represents complex numbers. So z is equal to 3 plus 4i. If I plot that now, that is just 1, 2, 3 of 4 right here. So that is it. Right. No difference from plotting like a real number. Okay. And the excuse me, the distance from the point to the origin, right? That's like your R value. We call it the magnitude of z. If you notice, right? It's the same as saying R is equal to square root of x squared plus y squared. Same concept, but in complex numbers, we call it z, the magnitude of the distance. All right, same concept right here. No difference. So now, just like we did with real numbers, we're gonna go from complex numbers, right, to polar form. So here we're going to go from z to polar, okay? Which the way we do is a little bit different from the real number. That's why I put polar right there. And then we go from I'm going to put complex, from z to complex polar, all right? And then from complex polar back to z, all right? So we're going to do both ways. From complex polar now back to, from complex polar back to z, all right? The concept is very similar, but we do one more step here. Same concept, guys. So, all right. So here we go. Okay, watch this. All right. All right. So here we go. We have a complex number, and we want to write it in polar form. Now, the polar form is a little bit different, but the steps are still the same. Okay. First thing we got to do is we must find R and theta. And this is very similar to like the real numbers. Find R and theta. So let's see. Okay. Let's use right here. Okay, let us practice for a second. We have -3, right? So -3 is over here. 1, 2, 3, and split of 7. Split of 7 is between 3, 2 and 2. I'm just going to guesstimate. Let's see what that is. Split of 7. I want to put it on the guesstimates. I should notice. Control 7. That's That's from, let's call it 2.6, right? So 2.6. So 1, 2, 3, and 2.6, somewhere around there. That's that point right here. Okay? That's it right here. All right. So again, you go from complex number to polar form. First, you must find your R and theta. And it's very similar to what we did with real numbers. Okay. All right. So let's find our value now. So our value is this distance right here. Good. And that's just the magnitude of z. All right. So this we can call R. R is equal to that. So R now is going to, I'm going to go over here. R is equal to the square root, right, of -3 squared is 9. Square 7 squared is 7. Everybody see that? 9. Square 7 squared. Square 7 squared is just 7. That gives me 7 right here. Good. And then that gives me the square root of 16, which is equal to 4. So R is 4. Good. All right, R is 4. All right, so R is 4. Now the angle, remember what we did in real numbers, right? Angle is equal to tangent inverse of y over x. What's the y value? All right. Okay. This is like the y value here. That's the y value. So it's going to be square root of 7 over the x value, which is negative. That's the angle. But remember now, this is a negative number now. So it's going to put you down here in the fourth quadrant. But my angle is up here. So we know we're going to add pi. Okay, just make sure you understand that concept. Pi. So we do that now. That gives me, calculator really quick. Trig function, tan inverse, and then I'm looking for split 7, and that's over -3. That gives me negative. Okay, so that's going to give me negative 0.722. I'm going to include one more decimal. Okay, negative 0.7227. And then I'm going to add pi to it because why? Because the angle I'm looking for is in this second quadrant. Okay. So when I add pi now, plus the pi, that gives me 2 point. Now that gives me now. I'm gonna run it off now. 2 point are truncated. 2.41. I'm just gonna truncate it. 2.41. All right. So my R value, my angle now is theta is equal to 2.41. Good. All right. You would think that's the end of it. Well, this is complex number now. We got to take it one more step. Okay. Let's go back to, all right. So the x value, x, y, that's what I want to get. But remember in polar form, right? X is equal to what? R cosine theta, and y is equal to r sine theta. Good? Now, so here, sometimes this is written as z is equal to x plus I times y. Sometimes it's written as that. Same format. All right? So my x value is r cosine theta plus I times r sine theta. Okay, hope you guys see that, right? Maybe I should talk about this before I start solving. Z equals A plus BY. Sometimes it's written as X plus IY. They're the same thing. Okay. So now my X, now I'm going to replace X with R cosine theta and a Y with R sine theta. That's how you write complex numbers in polar form. So that's why now there's one more step we got to do now. So now, right? So I'm going to get now in polar form, that's going to equal to R is 4 times the cosine, what's my angle? 2.418 plus, again, we'll put a plus because that's how polar form is written as, right? Plus BI plus 4 times sine of the angle, and the angle is 2.418. Remember, there's an I right here. Don't forget I. Okay. And then this is a long one, huh? Okay, and then we just do it then. What is cosine of that? Cosine of 2.48. We're about to trade them with the cosine of 2.4188. Okay, 6, that gives me times 4, right? Times 4 now, times 4, and that gives me negative, it's been -3, okay? Times 4, that comes up to be -3. Okay, I'm going to draw a line for this guy. That's not going to look, that gives me -3. Plus 4 sine of 2.48 now. Sine of 2.4188. I'll use a 6. Shouldn't give me much difference. And that's going to be times 4 times 4. That gives me 2 point. So it's going to be 2.64. I'm going to truncate 5 and make sure you put the I right. That's it in complex form. Okay. So that is your answer. All right, guys. So we're going to talk about complex numbers now. Okay. How to convert them from complex numbers to polar form. All right. So we're going to go from complex numbers to polar, we call it like complex polar form. Okay. That's a little long. All right. And then reverse that. Give you complex polar form to write in complex numbers. All right. And complex numbers, you saw this in Algebra 2. This usually arises when you use quadratic formula. Go back and look at it real quick. You know, remember you use quadratic formula, you have x is equal to minus b plus or minus the square root of b squared minus 4ac. Remember that? Over 2a, right? And then when you solve this now, you have to have two answers. X is equal to minus b, right? Plus the square root of b squared minus 4ac over 2a, right? And 2a, you can divide 2a into the minus b, okay? And the other one, now, and then you have x is equal to minus b minus square root of b squared minus 4ac over 2a. I don't want to do an example, but now we get a complex number when this number right here, this number, when this is less than 0, we call it discriminant. When this is less than 0, you get a major number, right? So for instance, if you solve this right here, you get square root of say the plus and minus, and that's where, right? That's where you get the complex numbers. And so the minus b is the real part. This gives you the imaginary number when the discriminant is less than 0. All right. And so let's go back here. Let's quick review. I don't want to go back into algebra 2 stuff. And so it is written as z is equal to 3 plus 4i. This is the real part, and that is the imaginary part. And this is the formula right here. And sometimes you'll see it written as z is equal to x plus iy. Same concept, right? The x, the real number, and the imaginary part, x plus iy. And we can plot these points on a plane. It looks like the real plane, but the x-axis is a real number, and the imaginary number is the y-axis. And if you do advanced math, there's a course called complex numbers, just deals with a lot of stuff right here. All right, so we just hit the basic part of it, give you the introduction to complex numbers and how we graph them and also convert between complex numbers and polar form. All right. Okay, so and we can plot like real numbers, right? Like real numbers. And so 3 plus 4i. This is the real part. So on the real axis is 1, 2, 3. 4i. We go 4 on the imaginary axis. So 1, 2, 3, 4. That would be 1, 2, 3, 4. That's how you plot those points. All right. So and then this right here, if you notice, right, this is like your r x squared plus y squared. All right, that's your r value. So we can the distance from the point to the origin, right? And in complex numbers, we call it the magnitude of z. But it's really like your r value, r equal to that. That's what it really is. All right. Okay, so that's kind of give you a kind of lowdown on that one. So now, how do we convert now a complex number to polar form? Okay, it's very similar to real numbers. Like if you're working with real numbers, we take it one more step, right? So you got to find your r and your b. Okay, and after you do that, you go one more step, which is very simple. All right, so here we go. So my r, which is just a magnitude of z, right? So let's look at number this example right here. I'm gonna plot this point right here. So let's say this is negative 3 plus I squared 7. Good. So I'm gonna plot that now. So negative 3 is 1, 2, 3, and square 7. Somewhere between 2 and 3. I think it's 2 point. Let me back over there. I think it's 2.6. So 2.6 is somewhere around here. Let's call it right there. Not 3. Okay. All right. So that's the point on the complex plane. We call it the complex plane. And now I want to find r. If you notice, it's just very similar to I'm gonna find r value, which is the magnitude of z. So r, or the magnitude of z, is equal to the square root of negative 3 squared is 9 plus square 7. We'll square that, it's 7. Hope you guys see that, right? And that's going to give me 16, which is equal to 4. That's your r value. The angle now, just remember I told you before, it's going to be tan inverse of y over x. What's the y value? Well, the y value is it's going to be the square root of 7. So it's going to be square root of 7 over the x value, which is negative 3. All right. Now, because this is going to be a negative input right here, we know it's going to return an angle in the fourth quadrant. That means right, I'm going to have to add, because the angle I want is in the second quadrant, I'm going to have to add a pi to that one there. Good? And so when I do that now, tan inverse, what do I get now? Okay. So tan, if I put this in calculator now, tan inverse, right, it's going to give me negative, that's going to give me negative 0.722. I'm going to go one more place over, okay? Because that's not my final answer, right? But my final answer, so I'm going to include an extra decimal place. But now I know I'm going to have to add pi to this, okay? Because the angle I want is in this second quadrant. So when I do that now, I add pi, that gives me 2 points. That gives me 2.418. Just truncated. I'm truncated. So that's the angle I'm looking for. Good. So my angle is 2.418, and my R value is 4. Remember I said that? Now, here is the one step you got to go for now. Okay. So remember, I told you, right, this is a complex form. We can write it as x plus iy. But what is x? Right, this is what we got to do. We're going to replace x with r cosine theta and plus y is r sine theta. That's it. So I'm just going to write it in that format. So that's going to give me now, right, r is 4, right? R is 4, cosine angle is 2.418. Got it? Plus I times R is 4, sine angle, which is 2.418. Okay, and that's it. That's it. That's how you write complex numbers. This is how you write complex numbers, right? Complex numbers in polar form. And you can, if you notice that 4 is common to both terms, right? I can factor 4 if you want to. I mean, all right, I'm not gonna kill you over this. Oops. I'm not gonna nick you for this one. But 2.418, all right, plus I sine 2.4. That is it. That's it. In complex form. So you know it's very similar to real numbers. You just take it one more step. That's it. All right, guys. All right, let's look at now how do we convert this if you give polar form now, how do you go back to complex? All right, and the key now is you got to find your R value, right? You get to find what you want to find is got my phone vibrating. All right, I'm back. Hey, so real quick, where we at now? Okay, we'll convert from polar to complex numbers. Okay, this one's pretty easy. All right, guys. So we know in complex we know polar. Okay, so we know in complex form, right, is z is equal to x plus iy. Right? X, right, is just r cosine theta. Y is r sine theta. Right? What is r? Hey, that's r right there. What's my angle? Pi with 3. This is this is part of it. All right, boom back. So all we got to do now is x is going to equal to, so r is 3 cosine of the angle, cosine of pi with 3. Cosine pi with 3 is 1/2, right? So 1/2 times 3 is just 3/2. And then for y now, y is going to equal to, let's erase this for a second. That's going to give me 3 times sine of pi over 3. Sine of pi over 3 is equal to, that's going to give me 3 times with a 3 over 2. And so in complex form now, we're going to get z is going to equal to 3 over 2, or 1.5, right? Plus I 3 right equals 3 over 2. That's it. That's it. So going from the polar compass form back to regular form is pretty straightforward. All right, so let's see what's next now. Okay, oh, this is the okay, this is the practice now. I guess I'm gonna have you guys try these on your own. Try this on your own, okay? Just to plot the points. You guys can do that real easily. Name the 4 different points. Okay, this is a good example again. Name the 4 different points, right? Here it is. What do we have here? This is 3 power 4. R is 1, 2, 3, 4. So R is 4. It is 4. Come on. 4 comma 3 power 4. Okay. And so remember now, we can go, we can flip the sign, right? R value minus 4. Then we're going to add pi to this. 3 pi over 4 plus pi, or minus 4. How do I plus right here? Comma. Okay. Minus 4, comma, 3 power 4. I can also minus pi from this. Right? And then the other 2 is, don't put R, just say 4, comma, 3 power 4. But this time I'm going to add 2 pi and then 4, right? 4, comma, 3 pi over 4 minus 2 pi. So those are, you can simplify that. Those are the 4 different ways. All right, guys? Okay, that's number 4 right there. And then number 5, convert to rectangular again. Remember, the formula is right. This is a regular polar points. Convert to rectangular. X is equal to R cosine theta, and so and Y is equal to R sine theta. You guys can do that. Okay. Convert again here. You want to convert to polar coordinates. The trick here is this, right? If you got to know when to add pi and not to add pi. So in this case right here, right, this point is in the first quadrant, 2, 4. It says right there. When I find the angle, the input is positive. Theta is equal to tan inverse of y over x, y 4 over 2. The input is a positive, so it's going to give me the angle I'm looking for is the same angle. It's the same angle right here. So I don't have to add anything. That is fine right here. Because the input is positive, it's going to tan inverse. It's going to return an angle in the first quadrant. But guess what? The point is in the first quadrant. So I'm good. Okay. This one, you're going to add pi because this point is in the second quadrant. It's in the second quadrant, but we take tan inverse now. It's going to give you an angle in the fourth quadrant. So you get to add pi afterwards. All right? All right, just make sure you understand. And here, this angle, this point is going to be in the fourth quadrant. All right. So when you find the angle, right, it's also going to be in the fourth quadrant, but your angle is negative. So you have to add 2 pi to this one. All right. Just make sure you understand how to do those. What's next? Very, guys, very simple again. I'm not gonna, again, it's the same thing we did before. Um, uh, Gotta be careful on this one too. This is very similar to when you find an angler, right? Uh, you gotta find again. Let's do number 11 very quick. Uh, okay, you know what? Yeah. It didn't give you a restriction. All right. So when they get a restriction, but still, let's do this one. Let's do number 11. So let's plot the point. Let's give that a quick reference. So three, positive three, 1, 2, 3, down four. So that's the point right there. Okay. Oh, okay. It's good to read instructions. It says plot the points. I am thinking we got to write this in polar form. Okay. Always good to read the instructions. So I'll get his plot notes. This is what I'm thinking. This is what I have in mind. Okay. Let's do number 16. All right. I think number 16 is very interesting. If you can do number 16, then you should do it already. And number 17, those are fine. It's x equals r cosine theta. All right. I mean, you can put it as in rectangular form. It's going to be z is going to equal to r cosine theta. That's the x value plus I times r sine. That's the y. That's the and that's it for 17 through 19. Hey, look at number 16. Yeah, very interesting one. Let me plot this real quick, right? Let's plot number 16 here. So I'm doing number 16. So negative 3 and 1, 2, 3 down 3. So that's a point right there. All right. Okay, here we go. So I need to find my R value. So okay, R is going to equal to square root of 9 plus, oops, 9 plus 9, which equals square root of 18. And I can write this as 3 right equal to. Hope you guys see that. Okay, so that's my R value. My angle now is going to be angle is going to equal to the tan inverse of y over x, which is negative 3 over negative 3. Now, this gives you a positive number, right? That gives you a positive, right? It's going to be positive. So therefore, let me do this real quick. Just want to make sure. That's why I did this one. That's going to give you tan inverse of positive 1. Okay, so my angle now is going to be, when I take inverse, it's going to put me in the first quadrant. Okay, and hopefully by now, if you take the inverse of tangent 1, that's going to give you pi over 4. Okay, that should give you blah, 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 0.7. I should give it pi over 4, which is 0.7. Oh, you know what? I'm thinking of radians. So you should give it. I'm just trying to figure out. I'm doing it in my head, but it's not working out. Okay, yeah. So yeah, it gives you 0.7. 0.785. Again, it's 0.785. But I'm going to go to another decimal. Let's go to 3. Okay. All right. So it's going to return an angle now in the first quadrant over here. Good. But that's not what I want. I want this angle right here. So what should you do? recognize, right? It's on the same line. So it's gonna add pi. So the angle is gonna be that's why I want to use it. Very tricky. So you just add pi. So the angle I'm looking for now is gonna be you add pi to this plus pi. And when you do that now, plus pi, plus pi, come on. Pi. Okay, that gives you I'm going to truncate 3.926. That gives you 3.926. Good. All right, so now we have our angle now. So all we got to do is we have R. What's my R again? All right, so all we got to write this as, that's going to give me R is 3, color. So it's going to be 3 R value times the cosine, 3 radical 2, times the cosine of the angle, which is 3.926 plus I times R, which is 3 radical 2 sine of the angle, which is 3.926. And that's it. Let me double check real quick. Yeah, yeah. And if you want, you can just back it out if they are value. Okay. Okay. And then number 17 through those are pretty easy. Convert to pull. What is it? Convert the rectangular form. Convert. Convert. Okay. 17. 17 through 19. Oh, I'm like, they're the same. Okay. I think when I copy these things, they're the same. Okay. Okay. I think when I copy, when I snip and paste, I copy the same thing over. And here, okay, so this is going to start tomorrow's class. I'll graph this. This is a circle right here. And this we'll do in tomorrow's lesson. All right. All right, that's it, guys.